Okay, now let's see if we can get into the recursion slides. Okay, first let's do something we've done many times before. The following function returns the sum of a list of numbers using the accumulation pattern. And the test uses the function to sum the list 1, 3, 5, 7, 9. So just write that code. You know how to do this, right? Okay, all done? Yep, it's real easy. The sum is 0. For I in new list, the sum is the sum plus I. Return the sum. Okay, very, very, very easy. You've done it many times. Okay, but I want you to do this without a for or while loop. Five minutes to think about it and work on it and try to get it done. Okay, let's take a look. There's always a conditional execution in a recursion. And one possibility, you're at the base case. And the base case here is where the length of the list is 1. In that case, you just return the first element of the list. That would be the sum of the entire list. Then if you're not at the base case, there's a way to take one step down and combine the current value with what you were able to do with the one step down problem. In other words, you assume that there's a way to solve the one step down problem. And here's the one step down problem. This is where the function calls itself. The list under sum of the new list of 1 colon, that is, starting with the second element of the list, everything. Okay, that is the one step down problem. Okay, and you ever say how to solve the one step problem, the one step down problem? No, but eventually the one step down problem becomes the base case, and then you pop, 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 pop. You're done. It's not necessarily the simplest way to do things. As you can see, this is far more intellectually complicated than the simple accumulation pattern, right? Sometimes it's really miraculous the way it works. Okay, so what I would like you to do, I'd like you to just take 5 minutes. So I have now sent you all this code, and I'd like you to take it out to Python Tutor and walk through it, follow it, and see what it does. Okay, I'm not going to do it. I'm just going to let you do it. Hmm?
I don't think it's set out, Dr. Wilson.
The substitution code is not formatted properly. Not formatted properly. I don't understand why. What's wrong with? Let's see if I can. Crazy. Oh, well, okay. Guess we're not going to be able to do that this morning. I have no idea why Moodle is acting up like that. That's just text. Try that again. Okay, I give up. He's been able to do this. Well, let's go on to the next slide. I got this example from this source. Take a look at that. This is a perfectly good perhaps we can do it in here. Yeah, this is a really good free online textbook, the Runestone Academy's Python book. Yeah, follow it through here. See if I can send you the link. It's okay. Yeah, you can get to it that way. And that'll allow you to step through it with effectively the same thing as the Python tutor. It's actually built into the Runestone Academy. Okay, let's go on. Here's another good recursion problem. This one really doesn't have a simpler solution that I can think of. The problem is to flatten a list. And you're going to flatten something called in underscore list. And the list that you're flattening has a sort of deep hierarchical structure. The first list has 2 elements. And within that list, the second element also has 3 elements. And the third element in this list has 3 elements. And you want it to be just completely flattened, no hierarchical structure to it at all. 1, 2, 3, 4, 5, 6. And one issue that you come up with is you need to be able to determine if an object is a list. And the way that you do that is instance x comma list returns true if the object x is a list and false otherwise. Let's take about 5 minutes and see if we can get our heads into that one. The base case is you're just looking at a simple object, which is not really a list. Okay, let me take a look at the solution to that. Well, that just gives you an example of the is instance function. So we start out, this is kind of incorporates the accumulation process. The out list is the empty list. Then for I in underscore list, if is instance of I comma list, outlist.extend flatten of I. So this is where the function calls itself. This is where the function flatten calls the function flatten. If it's not a list, you just append the item I to the out list. And this works. You might want to take that later on and trace it through with Python tutor and understand how it works. Okay. Quicksort. This is a famous, maybe one of the most useful recursive functions of all. And I would not expect you to be able to do it within a class period. This is quite tricky. If the length of the array, so you're quick sorting an array, if the length of the array is less than or equal to 1, then you simply return the array. In other words, it was only one long, so there was nothing to sorting it. Otherwise, you create something called pivot, which is the element in the middle of array. And you do that by taking the length of the array and integer dividing by 2. Then, having located the pivot, you put the array into 3 pieces: the left piece, the right piece, and the equal piece. And this is unpacking of a tuple. So left, right, equal, equal, empty list, comma, empty list, comma, empty list. Then you take the things in the array and if the thing is less than the pivot, then you left.append, so you put it here. If x is greater than pivot, right.append, else equal.append of x. And then this part is not necessary. Print left, comma, equal, comma, right. I added this line so that we could follow it. Okay. Here's the example. When you start, the array was obviously not less than or equal to, the length of the array was not less than or equal to 1. So the first run through, the pivot turned out to be the element in the middle, which was 3. And the things that are smaller than 3 are 2 and 1. The things that are larger than 3 are 4, 6, and 5. Next thing that you're doing is you're sorting, you're calling the function on this thing. So the middle element, quote, is 1. The right element is, the right list is 2. And there is nothing to the left of 1. Then you went to work on the 4, 5, and 6. In the middle is 6, and left was 4 and 5. Then you worked on the 4 and 5, and you got 4, 5, and nothing in the middle. So the middle is 5, left is 4, and right is nothing. And then you've got the whole list sorted 1, 2, 3, 4, 5, 6. Probably want to follow this thing through Python Tutor. It'll take some time to absorb the way it is working. You're not going to do it right now. Okay. There are two great examples in mathematics of recursive definitions that everybody is familiar with. One is the factorial function. Factorial of 0 is 1, and the factorial of n is n times factorial of n minus 1. And then there's the Fibonacci numbers. F of 0 is 0, f of 1 is 1, and f of n is f of n minus 1 plus f of n minus 2. So for instance, f of 2 would be what? Would be 1. Okay, so you could follow that thing. You could follow that thing following the recursive definition. You could write down, just write down a list of the Fibonacci numbers, and always go back 1, 2, add 1, 2, add 1, 2, add. Okay. But I want you to do this without recursion. Okay. So I want you to create the Fibonacci numbers without using recursion. What you want to do is think of a back 1 and back 2, and just update back 1 and back 2 as you go along. Okay. So if n is less than or equal to 1, just return n. That takes care of 0 and 1. Else, and this is where this is not recursion. This is back 2, back 1 is 0 and 1. Then for I in range of 2 to n plus 1, f is m2 plus m1. And then you update m2 is m1, m1 is f, and finally, when you're done, you return f. Okay? Fibonacci sequence. 0 and 1, you have to get 1. 1 and 1, you have to get 2. 1 and 2, you have to get 3. 2 and 3, you have to get 5. 3 and 5, you have to get 8. 5 and 8, you have to get 13. 8 and 13, you have to get 21. Okay. That is the end of my slideshow for today. And let me get turn editing on. And I will make recursion section visible. Okay, so Thursday, the last thing I'm going to do is we're going to talk about data analysis. And obviously, since I'm doing the material Thursday, you're never going to be responsible for the material, right? So what I'm doing is just sort of introducing you to data analysis and hopefully getting you interested in it. Because I teach it, that's what I normally teach is data analysis. So I love that particular topic. It's how do you use data to answer questions? And as a sample, what we're going to use is weather from the Olympia Airport collected over a fairly lengthy period of time from 1941 to essentially the present. And we're going to ask questions about what you see in Olympia weather. There's some interesting answers to questions you probably never thought of. But after you thought of them, you'd say, oh yeah, that is an interesting question. Okay. I'm also going to demonstrate to you that the facilities now exist so that you don't have to know much about coding to answer interesting questions about data. That is, if you're willing to pay a $20 a month subscription fee to OpenAI to get access to ChatGPT Plus, You can do amazing things knowing almost nothing, except how to ask a question. Okay, so it's time to get up and move around.